following up on the notion of whether or not we can identify what the costs are to deliver fuel, and if we could actually put them into a formula, we didn't really know the answer, so we had to find out what we could do. So we embarked on a fairly big journey, and the journey was to try to see if we can figure out what all these components were. So instead of just guessing and going back to the norms, the industry norms, we put together to the best of my knowledge, the largest survey that our industry has ever done. It was a survey. We took some clients that we had obviously delivery information on from their back office, the back office systems that they use, and we tracked slightly over 100,000 routes that were dispatched by these companies over the course of the year. The routes were driven by somewhat over 1,000 delivery trucks. There were over 2 million deliveries. There were over 400 million gallons delivered, and actually almost 12 million miles driven. So pretty big, pretty comprehensive study. It was heating oil, it was propane, it was rural areas, it was suburban areas, it was urban areas, a real mixed bag to try to see if we can find out what the components were before we even built the formula, what information was out there that we could just look to learn off of. And we were able to find some very interesting things, and the reason I think that they were interesting is that they're fact-based. And what I found, the key thing to me is that there was a lot of consistency. There weren't numbers all over the place. If there was a decent sized company, then there was a good deal of consistency. So in the listing of facts, the first thing that stood out to me was simply, we have this notion, and it really is what motivates me every single day. Our industry is chock full of excess capacity. Capacity in lots of different ways, but the two main ways that I see this capacity is, number one, the average delivery into an average tank. So that's heating oil tank and propane tank is roughly 50% of the tank's capacity. In plainer terms, a 275 gallon heating oil tank typically gets a delivery in the area of 140 to 150 gallons, slightly more than 50% of the entire tank capacity. With propane, considering that your capacity is not the exact full tank size, it's closer to 80%, a 500 gallon tank, which has capacity to fill about 400 gallons, typically gets a delivery of somewhere around 210 gallons. It's usually about half, which also means that you're probably having very few runouts, but you're not letting the tank get too close to empty for the runout reason, but you're also delivering when it's half full every single time. So does that make a lot of sense? That was number one. The second idea, or the second fact, as it were, on capacity was simply the truck themselves. Very typically speaking, I'll go back to heating oil for a second. A 275 gallon tank, we already know it gets filled up, but the truck that's making the delivery, the 3,000 gallon tank wagon that's out to make a delivery, what happens with that? Well, what happens is you start off your day full, whether you filled it up the night before, you filled it up that morning at the rack, and you go out and you make your deliveries, and sometime over the course of the morning, after 4, 5, maybe 6 hours, you have pretty much emptied out that truck. You go back and you fill it up again. You take your lunch break, whatever your protocols are. You go out and you go back to your zone and you finish up your day. Well, while you're finishing up your day, you only have another couple of hours, and you're typically going into that second truck worth, 500, 1,000, 1,500 gallons. Typically speaking, you're coming back at the end of the day. You're finishing your route with about a half of a truck, maybe a little bit more, delivered from that second truck. So you pretty much ending, I have a half a truck worth of oil, I just ran out of time. So I have excess capacity in the individual tanks that I'm delivering to. I have excess capacity in the truck when I bring it back at the end of the day. Some other things which are less surprising, they really do make sense. The typical dispatch truck is out between 8 and 9 hours of time. Of the 8 to 9 hours, probably between 5 and 6 hours of that time is spent delivering fuel. The rest of the time is drive time to and from a zone, filling up a truck once or twice, taking a morning and an afternoon break, taking a lunch break. So it's all important time, it's all productive time, but the actual delivery time is probably between 5 and 6 hours out of your 8 to 9 hour delivery day. Then it kind of gets interesting as far as capacity again goes. The typical truck, so if you're looking at a truck that can deliver about 4,000 gallons in a typical day, and you say, well, now I have 250 days a year, so clearly a truck can deliver 1 million gallons. It's absolutely true. However, not all your trucks are on the road every single day of the year. As a matter of fact, 40% is a pretty consistent number. A truck is typically on the road about 800 hours per year. A truck is on the road typically about 100 days per year. If you think of the logic, it's there because you need everything in January, but during the summer when your yard is full of trucks, those are just days that they're not being used. So 40% of your trucks are being used on any given day, obviously 100% during the month of January or thereabouts, and maybe only 10% in the months of July and August. Typical truck is delivering somewhere between 350 and 400,000 gallons per year. One important thing that came out of it also, or at least we found important to be, is what the proper metrics are. People look at metrics of gallons per hour. Great, 500 gallons per hour, good number. Compared to what? Well, let's just see. Stops per hour. Stops per hour is pretty straightforward. All right, gallons per delivery. All of these things add up. They're all metrics. But when you're looking at metrics, you really have to figure out, first of all, are they accurate? Second of all, do they tell you anything? Third, most importantly, can I do anything with this information? One of the more popular metrics is the cost per delivery. How much does it cost me to actually make that delivery, to go out to a customer's house? What's interesting is that everyone can calculate a cost per delivery. If you take all of the costs and you divide it by all of the deliveries, you will get a cost of a delivery. It's a numerator and a denominator, but when you're looking at cost per delivery, are you looking at the right thing? Meaning, if you come up with a $50 or $60 or $70 cost to make that delivery, then what? Is that a good number? Is that a bad number? Is it skewed? Maybe lower because you're making a lot of small deliveries. So can you artificially move that number? Not on purpose, but can you come up with a number of $40 per delivery, which is clearly better than $50 per delivery, but maybe it's not really better. Maybe you're just making too many deliveries and it's weighing down the cost per delivery. We believe that the appropriate number is the cost per delivered gallon. You have a certain number of gallons that you have to deliver. You can't really manipulate that all that much. You have to take care of your customers. You have to deliver your 5 million gallons, your 10 million gallons, whatever your weather normalized volume is going to be. Those are the gallons that you have to deliver, no matter how you're doing it. Whether you have one truck or 100 trucks, you have certain gallons that you are obligated to or you want to deliver. And you have expenses against those. So from our perspective, our goal in devising this survey, getting the data and trying to incorporate it down and distill it down into numbers was, can we determine what the cost is for you as an individual company to deliver a gallon? What is the cost per delivered gallon?